Hello everybody and welcome to my channel. Today I will solve several mechanics problems from FE Civil Engineering exam. So let's start with the problem number 1. In a simply supported beam under a uniformly distributed load W, Newton per meter over a span L, the maximum shear force at the supports is given by. So we have a simply supported beam like this. This is the beam, simply supported, and it is loaded with a uniformly distributed load W, Newton per meter. This is W. And the span is L. So the maximum shear force at the support is given by. Now, because of symmetry, we know that the reaction will be equal, or the entire load, which is WL, the load over the resultant is WL. So it will be half will go to this support and half will go to this support. So this is going to be WL over 2. And this is the same, WL over 2. So the maximum shear at the support is WL over 2, which is B. Next question. For a simply supported beam, again, with a concentrated load P applied at midpoint, the maximum bending moment is. So again, we have a simply supported beam with a concentrated load midway. Simply supported beam. This is simply supported beam. This is a simply supported beam again. And it has, it's loaded with a concentrated load P at L over 2. This is L, the span is L, and this is L over 2. So the maximum moment, the maximum bending moment, we know that the maximum bending moment at this case occurs at mid span at L over 2. So first the reactions, again, because of the symmetry, so half of the load will go to this support and half will go to the other support. So this is going to be P over 2, the reaction. And this is going to be P over 2. So the moment at L over 2 is the distance by the reaction, which is P over 2. This is the load multiplied by L over 2. So the maximum moment is P L over 4, which is B. So this is the correct answer. Next question. Okay, let me remove this. Again, consider a simply supported beam with a roller support at one end and a pin support at the other end. Which reaction forces are provided at each support? Now the pin prevents movement in two directions, in the X and the Y. Now the roller prevents movement in one direction, which is the Y. So at the roller, there's going to be one reaction in the Y direction, and at the pin, there are going to be two reactions at the X and at the Y direction. So let's see the options. A, the roller provides only a vertical reaction, that's correct, while the pin provides both vertical and horizontal reactions. So A is correct. So I think we don't have to go through all the other choices to save time and take the exam again. If you are sure of the answer, you don't need to go to the other choices. If you are not sure, you may go to the other choices. So the next question. When using the method of sections in trust analysis, it is essential to limit the number of unknown number forces cut by the section to ensure solvability. What is the maximum number of unknown members that should be intersected by the section in a two-dimensional truss? Now, when we do a section in a truss, now we have three equations of static equilibrium, which are sigma Fy equal to 0, sigma Fx equal to 0, and sigma M at certain point equal to 0. So we have three equations. So the maximum number of unknowns should not exceed 3. So we can have a maximum of 3 unknown forces in the members. We cannot have 4. So it should be maximum of 3. So the answer is 3. C. Next question. For a circular shaft, let me remove these. For a circular shaft, under torsion, the polar moment of inertia J for a solid circular cross-section with diameter D is given by. So you should remember this, the polar moment of inertia for a circular shaft, which is by D to the 4 over 32. So the correct answer is A. So this is you should remember. The moment of inertia, the polar moment of inertia for a shaft is by D to the 4 over 32. The moment of inertia for a rectangular cross-section BH cube over 12. So you should remember this formula. Next question. So the term strain hardening in a ductile material refers to. Now, there are always questions about the stress-strain relationship for a ductile material in the FE exam. So you should understand the different key points on the strain-stress relationship. Like point A is the elastic point, point B is the yield point. Here there is E is the ultimate stress point, and point F is the fracture point. Now, strain hardening refers to an increase in stress required to continue plastic deformation as the strain increases. Now, in this region between D and E, this is the strain hardening. So we are still stress is increasing, and strain is also deformation is increasing. So D to E is the strain hardening region. So the answer, an increase in stress required to continue plastic deformation as the strain increases. So the correct answer is A. Now, if you want to eliminate, you can do a decrease in material. So when you say strain hardening, so it does not mean decrease, it should be increase. Sudden fracture, this is not strain hardening, this is failure. The linear elastic behavior, so it is not also the linear elastic behavior is up to point A. A is the elastic, B is the yield point where the deformation stress deformation can still be recoverable. So the correct answer is A. The next question. Now, in a stress strain curve obtained from the tensile test, the area under the elastic region represents. So this is again a question about the stress strain diagram. which is something important. So it asks about the area about the elastic region. Now, the area is the material toughness. No, the material toughness is the area under the entire curve until failure. So up to point A, the area up to point A under the curve up to point A is the toughness. Now, the area under the elastic strain under the elastic point A or B is known as the the elastic strain energy per unit volume. Elastic strain energy per unit volume. Now the question says, in the stress strain obtained from tensile under the elastic region. So it says under the elastic region, so it should be, the answer should be the elastic strain energy. It should not be under the entire curve. Should not also be the yield strength. The yield strength is different, the ductility. So the answer is B. Now the area under the stress strain diagram, this is just additional information. Now the strain is dimensionless. The stress is force, or force, that's Newton per meter square. So this is the stress multiplied by dimensionless. So the area is Newton per meter square. Now, if you multiply both numerator and denominator by L, the dimension L, which is meter, so we will have a Newton meter, which is work or energy per meter cube per unit volume. So the area under the stress strain diagram is energy per unit volume, which is the stress again. It is stress, but it is also energy per unit volume, because this type of question repeats in the FE exam. Okay, the next question. When designing a reinforced concrete slab for punching shear, which factor is most critical? Now, for punching shear, the important, or what is this, the shear is the thickness of the slab. So it is effective depth of the slab. The shear is controlled by the depth of the slab. Next question. In dynamics, the impulse momentum principle states that change in momentum of an object is equal to the impulse applied to it. So change of momentum is equivalent to the impulse, or rate of change of momentum is equivalent to the force. Now, which equation best represents this principle? Now, if delta T, this is force by time, delta P is the change in impulse. Now, BF equals MA, this is Newton's second law. P equals MV, this is impulse. It does not relate the force or the impulse to the change in momentum. And F equals delta P over delta T, this is force. So the correct answer is A, because it relates the force with delta T and change in momentum. It relates force or impulse with change in momentum. Now this relationship is very simple actually. You can, if we define A, what is the definition of acceleration? So acceleration is delta V divided by delta T. This is the acceleration. So delta T multiplied by acceleration is delta V. Now if you multiply both sides by the mass, so mass MA delta T equals M delta V. So MA is force, so force delta T, this is impulse, equals delta P, change in momentum. So force impulse equals change in momentum, which is if delta T equals delta P. Next question. The principle of superposition in static analysis is valid only when the system behaves in nonlinear manner. Yeah, it should be nonlinear, elastic and nonlinear, elastic manner, time dependent. So the correct answer is plastic and nonlinear manner. So we can apply principle of superposition if the material is in the plastic range and if the equations are linear. So the correct answer is B. In the analysis of a planar truss using the method of joints, how many independent equilibrium equations are available at the joint? Now, joints carry can carry only tensile forces, tension or compression. Now, at a joint, we can or we need two equations. So at a joint, how many independent equations we have? We have two equations, which is sigma fx equals 0, sigma fx equal to 0, and sigma fy equal to 0. These are the equations that we can apply at the joints. Now, when we make a cross section, we have an additional equation, which is sigma moment at a certain point equal to 0. Next question. For a point located at a distance r from the axis of rotation, the tangential acceleration at is related to the angular acceleration alpha by which expression? This is the relationship between tangential acceleration and angular acceleration in circular motion. So the correct answer is A. The tangential acceleration is related to the angular acceleration by radius. So A tangential equals alpha, which is angular acceleration by r. The next question, the shear force at a section, okay. The shear force at a section of a beam is mathematically defined as the derivative of which quantity with respect to the beam's length. Now, shear force is the derivative of the moment. V of x is the derivative of n of x. W load, W of x is the derivative of the shear. Moment is the derivative of the deflection. So these are the mathematical relationships between shear, moment, and load, and deflection. So for this question, the correct answer is C. So the shear is the derivative of the moment. Next question. For a system in elastic equilibrium, what must be true about the sum of moments about an arbitrary point? Now, for a system in static equilibrium, summation of moments should be 0. It equals, now it says at an must be correct about summation of moments. Yeah, about sum of moments. So it equals the sum of forces. So this is not correct because moments are not forces. You cannot say that summation of moments equals summation of forces. So you can eliminate A. It equals the net external moment. This is not necessarily true. It is 0. It is equal to the applied reaction moment. Again, D, you can eliminate D because it says that it equals the applied the applied reactions moment. Also, this is not necessarily true. So C is the correct answer, which says that it must be 0. The summation of moments at an arbitrary point must be 0 because the object is in static equilibrium. The next question. A vehicle of mass m travels at a constant speed v along a circular path radius r, which formula correctly calculates the centripetal force acting on the vehicle. So the centripetal force is mv square over r. This is a very well-known formula. You should remember this formula. This equals the centripetal force, which goes towards the center, and also the centrifugal force, which goes outward of the center. So this is the magnitude of this force is mv square over r. So the correct answer is A. You should remember this formula. Next question. Remove. In a free body diagram, the moment produced by a force about a specific point is determined by multiplying the force magnitude by. So moment is always force by distance. This is the definition. Moment is force by distance, and the distance and the force should be perpendicular. This is the key point. So this type of a question also repeats in the FE exam. Now, in this type of a question, when it asks about the relationship between moment, force, and distance, you should look to the word perpendicular. So the force and the moment should be perpendicular. So we have A, the horizontal distance from the point, not the horizontal distance, the vertical distance from the point to the force line of action, and the perpendicular distance. So it should be always the perpendicular distance. Again, this question repeats in the FE exam, and in this type of a question, you look for the word perpendicular distance. The next question, creep in materials is best described by. Now, creep is continuous deformation or plastic deformation under constant stress. So sudden fracture under high load, this is not correct, this is not creep. Time-dependent permanent deformation under sustained load. Now, elastic recovery, this is not creep, C. The progressive damage due to cycling load, this is fatigue. So the correct answer is B, which is time-dependent permanent deformation. So deformation will continue. And this is the strain, this is sigma. So there's going to be somewhere here continuous deformation under constant stress, under constant loading. So this is called creep in material science. Next question. Now, in tensile test, the reduction in area at a fracture is used primarily to assess a material's strength, not the strength, ductility, hardness, stiffness. So the reduction in area which occurs at just before failure. If you remember the stress-strain diagram for an elastic material, it was something like this. It starts linear, it goes up a little. So this is strain hardening. So this point is E for all ultimate, U ultimate strength. So this point is the fracture. So in this area or in this part, this is the necking, when necking occurs just before fracture. So this is a measure of the ductility, materials ductility. Again, the stress-strain relationship for ductile material like steel is always, there are several questions, or there can be several questions in the FE exam. So you should make sure that you understand this diagram very well. Now the next question, when beams cross-sectional moment of inertia increases while all other factors remain constant, the beam's deflection under a given load will now when the moment of inertia increases, the section becomes stronger. So the deflection decreases. Okay, so we increase the moment of inertia, the deflection should decrease. Okay, you should also understand this relationship. Next question. So we have the modulus of toughness. So the modulus of toughness of a material is defined as a total energy per unit volume that the material can absorb up to fracture, which is measured by. Now, toughness is the energy per unit volume up to fracture. Now, again, we go back to this stress-strain relationship. So toughness is the area under the stress-strain diagram up to fracture, this total area. And we said that this area, it is a stress, because when you multiply, this is stress, sigma, strain is dimensionless, length per length, so this is stress, and you multiply both numerator and denominator by length, which is m, so it became energy per unit volume. So it is energy per unit volume until under the stress-strain diagram until failure. So the area under the entire stress-strain curve, so this is the correct answer. Yeah. So the area under the entire stress-strain diagram, the slope, is not the slope, the ratio of ultimate strength, field strength, this is also not the definition of toughness. Area under the elastic portion is the elastic sustainability. So area under the entire diagram is defined as toughness. So that's all for today's video. If you have any question about any of the questions or problems solved today, please leave me a comment. If you have any problem you want me to address, please also send me in the comments. Thank you for following my channel, and I look forward to seeing you in the next videos.